Generation 1. The phone in your pocket is millions of times more powerful than the computers that helped put humans on the moon. And somehow, modern computing started with machines so massive they filled entire rooms, weighed 30 tons, and sounded like a power plant having a nervous breakdown. When people talk about first generation, second generation, all the way to fifth generation computers, they're not just talking about time periods. Each generation represents a completely different way computers were built and used. And by the end of this video, you'll know what defined every era, the machines that changed everything, and why we're already living in the fifth generation, while the sixth is quietly getting closer. It all starts in the 1940s, the era of glowing vacuum tubes, punch cards, and computers the size of buses. First-generation computers ran on vacuum tubes. These were giant glass electronic switches used to control electricity before transistors or chips existed. They worked most of the time, which is impressive considering they looked like fragile light bulbs powering national defense projects. The most famous machine was ENIAC, completed in 1945. It used around 18,000 vacuum tubes, weighed roughly 30 tons, filled an 1,800 square foot room, and cost about $500,000 back then, around $7 million today. After all that, it could perform about 5,000 additions per second. Your phone now does more processing loading a meme. Here's a piece of history most people never heard about. ENIAC's original programmers were 6 women: Kay McNulty, Betty Jennings, Betty Snyder, Marlon Westkoff, Fran Bilas, and Ruth Lichterman. They physically rewired the machine for every new calculation. No keyboards, no code editor, just patch cables and patience. They were uncredited for decades, even though they basically invented the job of programmer as we know it. Using one of these machines didn't look anything like modern computing either. There were no screens, no apps, no mouse, no restart and see if it works. Just walls of toggle switches, blinking lights, and panels covered in dials that looked more like a power station than a computer. Programming often meant physically rewiring the machine or feeding it giant stacks of punch cards. One misplaced hole could ruin an entire calculation, which is probably why early programmers looked permanently stressed in photos. Memory was primitive too. Some systems used magnetic drum memory, giant spinning metal cylinders storing data magnetically. Basically a hard drive, except it was the size of a washing machine. And reliability? Absolutely not. Vacuum tubes burned out constantly. ENIAC had failures every couple of days on average, so engineers walked around carrying replacement tubes like mechanics at a Formula One pit stop. Keeping the computer running was basically part engineering, part emotional support. The machines also generated enormous heat and consumed ridiculous amounts of electricity. Some stories even claim lights dimmed nearby when ENIAC powered on. Whether that's fully true or not, the fact people believed it tells you everything. But despite all the problems, these computers proved something revolutionary. Machines could calculate faster than humans ever could. This was the "we just invented fire" stage of computing. Powerful, groundbreaking, slightly dangerous, and absolutely not user-friendly. The downside was obvious though. These systems were so huge and expensive that only governments, militaries, and elite universities could afford them. Computers weren't personal devices yet. They were basically national infrastructure with overheating problems. Generation 2. The first generation proved computers were possible. The second generation made them practical. And the reason for that change came down to one tiny invention: the transistor. Instead of using giant, fragile vacuum tubes, second-generation computers replaced them with small electronic switches made from semiconductors. And compared to vacuum tubes, transistors were basically magic. They were around 100 times smaller, used far less electricity, generated less heat, and lasted dramatically longer, which meant engineers could finally spend less time replacing burnt-out components and more time actually using the computer. Computers still weren't small by modern standards though. They just evolved from entire room to aggressively large cabinet. Progress. One of the biggest systems of this era was the IBM 1401. Released in 1959, it became wildly successful with over 12,000 units sold, earning a reputation as the Model T of business computing. For the first time, companies outside governments and universities could realistically justify owning a computer. And once businesses got involved, everything changed. Computers started handling payroll, accounting, inventory, and banking operations. Instead of being experimental scientific machines, they became business tools. extremely expensive business tools, but still progress. Another important machine was the IBM 7090, which NASA used during early space missions. So while businesses were figuring out spreadsheets, these computers were also helping humans figure out how not to accidentally explode in space. Memory improved too. This generation introduced magnetic core memory, which stored data using tiny magnetic rings. It was faster, more reliable, and honestly looked like someone handcrafted a computer out of sewing supplies. This was also the era of those iconic spinning tape reels you've seen in every old sci-fi movie. The IBM 729 tape drives stored data on magnetic tape, and watching them whirl back and forth became the visual shorthand for computer doing computer things for the next 30 years. If a movie wanted to show a powerful computer between 1960 and 1990, it just pointed a camera at spinning tape reels. But one of the biggest changes happened in programming. During the first generation, programmers often worked directly with machine code, raw binary instructions made of ones and zeros, which is technically programming, but also looks like the computer is crying for help. Now, higher-level programming languages started appearing. Fortran arrived in 1957 for scientific computing, and COBOL followed in 1959 for business applications. Instead of writing endless binary instructions, programmers could finally use commands that looked closer to actual language. And weirdly enough, COBOL never fully disappeared. A huge number of banks and government systems still rely on it today, which means somewhere right now, there's probably a computer older than your parents processing financial transactions without complaining once. Quick question, have you ever actually seen or used COBOL? Drop a comment, because every time people mention it online, programmers appear like ancient guardians defending a forgotten language. And if you're learning something new about the machines that built modern computing, hit the like button. It genuinely helps the channel. Now, if the first generation computers were like steam engines, second generation systems were like the first practical cars. Same idea, way more usable. Generation 3. By the mid-1960s, computers were finally shrinking fast enough that people could imagine a future where they weren't locked inside government buildings humming aggressively in the background. And the breakthrough that made that possible was the integrated circuit. Instead of wiring thousands of separate transistors together individually, engineers figured out how to place multiple transistors onto a single silicon chip. That made computers smaller, faster, cheaper, and way more reliable, which was great news for everyone tired of treating computers like fragile industrial machinery with emotional problems. The defining machine of this era was the IBM System 360, launched in 1964. And this thing completely changed the industry. Before it, upgrading computers was painful. New hardware often meant rewriting software from scratch, which companies absolutely loved spending millions on. IBM fixed that by creating a system where the same software could run across different models in the lineup. For the first time, businesses could upgrade computers without also upgrading their stress levels. IBM ended up selling over 33,000 systems, many costing over $1 million each. Which means corporations in the 1960s were casually buying computers at small mansion prices. Then there was the PDP-8 in 1965, often called the first commercially successful mini-computer. And mini is still very optimistic here because it was roughly refrigerator-sized. But compared to earlier room-sized machines, this suddenly felt compact enough that smaller labs and universities could actually own one. At around $18,000, it brought computing to way more people. This era also changed how humans interacted with computers. Punch cards slowly started disappearing as keyboards and monitors became more common. For the first time, you could sit down at a desk, look at a glowing green screen, and type commands directly. Computers stopped feeling like industrial machines you fed paper into, and started feeling like something you could actually talk to. Operating systems also became much more advanced. Computers could now run multiple programs at once and support multiple users through terminals. One machine could serve an entire office at the same time, which was basically cloud computing before anyone invented the word cloud. And in 1969, something quietly appeared that still shapes technology today: Unix. At the time, it was just another operating system experiment. Now, its ideas live on in Linux, Mac OS, Android, and countless other systems. So technically, part of your modern phone's family tree traces back to a computer era where portable still meant can be moved by several determined people. Generation 4. This is the generation where computers stopped being machines for experts and became something normal people actually had in their homes. And the invention that caused that shift was the microprocessor. Instead of spreading a CPU across multiple boards and components, engineers managed to place the entire processor onto a single chip. One tiny piece of silicon suddenly replaced hardware that previously filled large sections of a room. The breakthrough came in 1971 with the Intel 4004, the world's first commercial microprocessor. It had just 2,300 transistors and was originally designed for a calculator. Once CPUs became cheap and compact enough, computers started shrinking fast. Then came the Altair 8800 in 1975, the machine that kicked off the personal computer revolution. It looked less like a modern PC and more like a box of switches someone forgot to finish building. But hobbyists loved it. Two of those hobbyists were Bill Gates and Paul Allen, who wrote software for the Altair. That software company eventually became Microsoft. So yes, one of the biggest companies in history partially began because people wanted blinking lights on a metal box. Then computers entered homes properly. The Apple II in 1977 made computers approachable for regular families and schools. The IBM PC in 1981 standardized business computing. And the Apple Macintosh in 1984 introduced millions of people to graphical interfaces and the computer mouse. Instead of memorizing commands, you could click icons and move windows around visually, which meant computers no longer required you to feel like you were launching a missile just to open a file. This was also the rise of the GUI, graphical user interface. Command lines slowly gave way to desktops, folders, menus, and buttons. Suddenly, even non-technical users could actually operate a computer without needing a programming manual nearby for emotional support. And then the internet arrived. Email, online shopping, multiplayer gaming, websites. All of that exploded during this generation, especially after Windows 95, which brought internet access into the mainstream and made personal computing feel truly connected for the first time. And after Windows 95, the upgrades kept coming. XP defined the 2000s. Windows 7 became the version people genuinely loved and refused to upgrade from. And modern Windows kept the formula going. The fourth generation basically lasted 4 decades because the microprocessor formula just kept working. This era was also driven by Moore's Law, the observation that transistor counts roughly doubled every 2 years. Computers became exponentially faster, smaller, and cheaper, at a pace that honestly felt unrealistic, even while it was happening. A computer that once filled a room eventually became small enough to sit on a desk, then in a backpack, then in your pocket. Quick question. What was your first computer? A Windows 95 machine? An old beige IBM? One of those colorful iMac G3s that looked like candy? Drop it in the comments, because everyone remembers their first computer the same way people remember their first phone. Generation 5. The fifth generation is different from everything before it. If the earlier generations were defined by physical hardware you could point at, tubes, transistors, chips on a desk, this one is defined by something invisible, intelligence. Earlier generations were mostly defined by hardware getting smaller, faster, and cheaper. But now, shrinking transistors isn't the main story anymore. The real shift is what computers can actually do. This is the era of AI, machine learning, cloud computing, and massive parallel processing, where computers stopped just following instructions and started generating, predicting, recognizing, and responding. One of the biggest reasons for this shift was the rise of the GPU. Graphics cards were originally designed for gaming, helping render explosions, lighting, and whatever was happening in a 2009 Call of Duty lobby. But it turned out GPUs were also incredibly good at handling the kind of parallel calculations AI models need. That discovery transformed companies like NVIDIA from the graphics card company into one of the most powerful players in tech. Entire AI systems now run on hardware that was originally built so games could have more realistic shadows. I personally think this is one of the most underrated plot twists in tech history. A company that built hardware so teenagers could shoot each other in Call of Duty accidentally ended up powering the entire AI revolution. Nobody saw that coming, including NVIDIA. This generation also put powerful computers into everyone's pocket. When the iPhone launched in 2007, smartphones stopped being tiny business tools and became full computers people carried everywhere. Modern phones now outperform supercomputers from earlier generations, while also somehow being used mainly for scrolling and arguing online. Then came the AI explosion. Voice assistants, recommendation algorithms, self-driving systems, image generation, real-time translation. Computers started handling language, vision, and decision-making in ways that once sounded futuristic. And in 2022, tools like ChatGPT pushed AI into the mainstream overnight. Suddenly, millions of people were interacting directly with machine learning systems, instead of hearing about them in research papers nobody finished reading. Another major shift is that your computer isn't just your computer anymore. A huge amount of processing now happens in cloud data centers spread across the planet. Streaming, AI tools, online games, backups. Your device is often just the front end, connecting to giant warehouses full of servers consuming enough electricity to power small cities. Hardware itself also became more specialized. Instead of one chip doing everything, companies started building processors optimized for specific workloads. Apple created its M-series chips. Google built TPUs for AI. And modern devices now include dedicated neural engines just for machine learning tasks. But there's another reason this generation feels different. Physics is becoming a problem. Modern chips are already around 3 nanometers, while atoms themselves are roughly 0.1 nanometers wide. We are literally approaching physical limits where components can't shrink forever without quantum weirdness showing up uninvited. Generation 6. So, if we're currently living through the 5th generation, what does the 6th look like? Right now, nobody fully agrees, but there are a few technologies that keep showing up in the conversation. The biggest one is probably quantum computing. Companies like IBM, Google, and dozens of startups are racing to build computers that solve problems classical machines struggle with, especially in areas like cryptography, chemistry, and massive simulations. Instead of normal bits that are either 0 or 1, quantum computers use qubits, which operate in ways that sound less like engineering and more like physics trying to confuse everyone equally. And it's already happening at scale. Google claimed quantum supremacy back in 2019, and IBM now has quantum processors with over 1,000 qubits. It's still early, still fragile, and still mostly useful for very specific problems, but it's no longer just a thesis project somewhere. Then there's neuromorphic computing, where chips are designed to mimic how the human brain works. Projects like Intel's Loihi and IBM's True North aim to process information more like neurons instead of traditional CPUs. Basically teaching computers to think less like calculators and more like biological systems. There's also research into DNA and biological computing. And yes, that's exactly what it sounds like, storing data inside actual DNA strands. DNA is incredibly dense for storage, meaning tiny biological samples could theoretically hold absurd amounts of information. Humanity somehow went from punch cards to what if the hard drive was alive? And then there are brain-computer interfaces like Neuralink, trying to connect computers directly to the human nervous system, which means future computers might not just respond to clicks or voice commands, they could respond to thought itself. But here's the important reality check. A lot of this is still experimental. Just like early AI hype, crypto hype, or even 5G marketing, the 6th generation won't arrive overnight. It'll happen gradually, one breakthrough at a time, while most people are still using their tech mainly to watch videos and ignore software updates. And that's the evolution of computer generations, from vacuum tubes to transistors, to integrated circuits, to microprocessors, to AI systems that can now generate images, write code, and sometimes confidently explain things completely wrong. And the biggest change had nothing to do with speed. Every generation changed who could use computers and what computers were actually for. They went from military machines to business tools to something billions of people carry in their pockets every day. So, which generation did you grow up with? Punch cards, MS-DOS, Windows 95, or straight into the iPhone era? Let me know in the comments. If this finally made computer generations make sense, then hit subscribe so you don't miss the next one. And if you want to keep going down the rabbit hole, I've picked the perfect video for you next. It's on the screen right now. Click it, and I'll see you there.